The first rule about oxidation number says that when the elements are uncombined, which means that they are pure, that they are not combined with other elements, the oxidation number will be 0. Example, sodium alone will be 0, for example, copper, magnesium. All elements, when they are not combined, are going to be 0. And also, the atomic elements like hydrogen, oxygen, chlorine, nitrogen, all of them also are going to be 0 if they are not combined. Now, hydrogen, when it is combined, can be +1 or -1. It is most of the time going to be +1, except when it is combined with a metal. For example, NaH is read as sodium hydride. The ion hydride has a charge of -1, but in the rest of the compounds, hydrogen will be +1. Oxygen, most of the time, is going to be -2, except when we're using peroxides. When you have peroxides, the charge for oxygen is going to be -1. And the compound OF2 is going to be oxygen +2. Remember that fluorine is always -1. Now, important that we read the other rule too. It says metallic elements, remember metals, have positive oxidation number. Non-metal has a negative number. No, all metals have positive oxidation numbers. In covalent compounds, which means two nonmetals at least, in covalent compounds, the negative oxidation number is assigned to the most electronegative atom. Then we have the algebraic sum of the oxidation numbers in a compound is 0, and when it is a polyatomic ion or an ion, is going to be equal to the charge. These 7 rules are going to be useful to solve all these exercises. Now, remember that I won't have all the time to solve the 30 exercises. So I'm going to practice with you. I'm going to be helping you to see how to work with this. Okay? Kenneth, do not forget to include your list number. Next to your name, please. Thank you. Okay, so the first thing that I want us to do is to identify those elements that are not combined. Let's identify the elements that are not combined.
The number 3.
The number 3, that is correct. The number 3 is not combined, okay? So we say that because of the rule number 1, we understand that elements, when they are not combined, the oxidation number is going to be 0, okay? What other element is not combined?
Number 20.
Number 20. This number 20, take a look. The number 20, yes, is an element that is not combined, but it has a charge, which means that it is an ion. Remember that elements, when they have charges, are ions. The rule says that when you have ions, the oxidation number is going to be equal to the charge. So in the case of the number 20, this one right here, because of the charge, even though the element is not combined, because of the charge, we say that the oxidation number is equal to -1, is equal to the charge. What element is not combined?
14 and 15.
Okay, 14 and 15, it is the same situation than the chloride ion that we just did. 14 and 15, they have charges. So the oxidation number are going to be equal to the charge. So here, the oxidation number is going to be equal to +2. And the number 15 is also going to be equal to +2 because of the charge, remember? Now, what other element is pure? Pure means that the charge is 0, okay? The charge is 0, but also not combined.
There's no more.
Okay, let me show you the 21, the 24, okay? The 21 and the 24, we just have one element, okay? And they're not combined to other elements. So when this happens, we say that the oxidation number is 0 because of the rule number 1, okay? Rule number 1, oxidation number equals 0 because they're not combined and they don't have any charge at all, okay? You see here, you see no charge because it doesn't have charge. We say they are uncombined, so the charge is 0. And if you are thinking about the number 25, Ca2 plus, in that case, the oxidation number is going to be what?
+2.
+2, okay? Now, I'm going to identify in yellow color. I'm going to identify. Okay, sorry, we have one more right here. The 19, magnesium 2 plus. What will be the charge for it?
+2.
Exactly. So when the charge is specified, you just need to write it down. Now, I'm going to identify in a different color, yellow, the compounds, not the compounds, the polyatomic ions. How do you identify polyatomic ions? Because you will have a chemical formula and you will have an exponent or a positive or negative sign in the upper right corner. Example, in the first column, in the number 8, I have a polyatomic ion because NO2, -1, okay? This -1 tells me that my NO2 is actually a polyatomic ion. So when you have a polyatomic ion, that means that when you solve for the equation, you will equalize to the charge. What other polyatomic ions I have in this first column? Only in the first column.
13.
The 13, that is correct. Is there any
The
other?
10.
The number 10. Okay, in the second column, do we have ions?
26 and 27.
26, 27. Is there any other?
30.
The 30. Is there any other?
18.
18. Okay, all of them, all of the yellow ones are polyatomic ions because you can see the charge. So the rule says that when you have polyatomic ions, you will equalize to the charge. Now, from the yellow exercises, I'm gonna help you with number, sorry, with number 18, with number 26, and with number 30. Okay, I'm gonna be working on those three. So let's take a look. The 18, I'm gonna write them and then I will project them. So the number 18, the number 26, and the number 30. In 18 is SO3 2 minus, 26 is CN minus, and 30 is C2O4 2 minus. Okay, so I'm gonna work with these three exercises here below. The rule says that when you have ions or polyatomic ions, you will equalize the addition of all of them. You will equalize to the charge. In this case, the charge is 2 negative, so this is going to be equal to negative 2. And then remember that when you don't see any subscript, means that the subscript is actually invisible 1. So here is gonna be the composition of this ion is gonna be 1 sulfur plus how many oxygens? How many oxygens?
3.
3 oxygens equalize to negative 2. Okay, the exercise says that we need to find sulfur, okay? The oxidation state for sulfur. So sulfur is going to be my unknown. Remember that coefficients as 1, they are invisible, so you can skip it. Now, what does the rule say about the oxidation number for oxygen? What does the rule say about the oxidation number for oxygen? What is the charge of oxygen?
That it will always be -2.
No, not always, but like 95% of the time it's gonna be negative 2. Okay? So, in this case, we solve for this multiplication. 3 times negative 2 is gonna give you negative 6. All this equalize to what you have in the other side of the equation, negative 2. Okay? Now, this negative 6 is subtracting. When you move it to the other side of the equal sign, it's gonna be doing addition. Okay? So, in the end, sulfur is gonna be equal to negative 2 plus 6, like that. How much is this?
4.
Positive 4. And that will be the answer. Sorry about the noise. That will be the answer for this. Now, take a look right here. Between, well, I don't know if you have a doubt in the exercise that I just did. Gerard?
You said that the 95% of the times we're going to use -2, right?
Yes.
But what other numbers can we use in that other 5% that we doesn't use -2?
The rule tells you. The rule tells you the only exceptions. When you have a peroxide ion, the charge for oxygen will be -1. And when it's combined with fluorine, but just fluorine, okay, then the charge is going to be +2. How do you know if you have a peroxide? Take a look right here. I have two compounds, very similar, but in the end, they are different. How do I know if I have a peroxide or I have an oxide? Peroxide ion is written as O2 and it has a charge of -2. The ion, okay, the ion peroxide is O2 and the charge is -2. But one single oxygen uses -1. So to know if I have a peroxide, I just isolate for the oxygen right here. I know that calcium is a metal that has a fixed oxidation number because I look for it in the periodic table, and it says that calcium can only use 2 plus as an oxidation number. So when you have all this information, you can isolate for oxygen in the same process that I explained, and you will notice that the oxidation number is -1. This -1 indicates that what you have right here is not oxygen, it is peroxide ion. In the case of an oxide, but you don't know it's an oxide, what is going to happen when you combine with calcium is that you will cancel the charges, but here below you're going to have invisible 1, and invisible 1 is not peroxide. And if you don't believe me, you can apply all this procedure to find the oxidation number for oxygen. In the end, you will notice that oxygen will be -2, and -2 is normal oxygen. There are very specific cases where it's going to be peroxide, but they are very, very, very specific. It's not too common. That's all I'm saying. Now, in the case of Cn minus, the ion cyanide, again, we have an ion. So we are going to equalize to the charge. The charge I see just a negative. That negative tells me that I must equalize to -1. Okay? Now, let's take a look to this rule. Because if you take a look in the periodic table, carbon can be plus minus 2, 4, and nitrogen can be plus minus 3, 5, and I don't know if 7, probably. All I'm saying is that the two of them, carbon and nitrogen, both have multiple choices. Okay? It's very difficult to tell what is the charge that they are using because we are looking for the charge. That's the purpose. But there are many possibilities, so we don't know what is the charge that is using. So for this kind of examples, we're going to follow the rule number 5. The rule number 5, the 5 states that in covalent compounds, okay, better. In covalent compounds, it says the negative oxidation number is assigned to the most electronegative atom. So take a look. I know that the rule in terms of words is kind of annoying because you don't probably know what that is, but it's actually very simple. you have a covalent compound. It is covalent because you have two nonmetals, okay? We have carbon and we have nitrogen. Also, SO3 is a covalent compound, but we have oxygen and we have a rule for oxygen, but we don't have a rule for carbon nor a rule for nitrogen. So we need to follow the rule number 5 that says that we're gonna be using the electronegativity to assign the negative oxidation number. So for that, I'm going to project this thing. Wait a second. Okay. Okay, are you seeing this table of electronegativities?
Yes.
Okay, take a look to the electronegativity of carbon. It is 2.5. The electronegativity for nitrogen is 3.0. Okay? Remember these values. Javier, are you in my class or are you being distracted by the TV or something else? Carbon is 2.5 while nitrogen is 3.0. So now I go back. I don't know if you are seeing my whiteboard now. Are you seeing?
Yes.
Okay, good. Now let's take a look. Remember what we say. Electronegativity for for carbon is 2.5 and for oxygen is 3.0. To confirm, I'm gonna check it again. Okay, to confirm. Yes, 2.5 and 3.0. Okay, so the rule says that the most electronegative, which is in this case is oxygen, sorry, it's not oxygen, this is nitrogen, which in this case is nitrogen. This is the one that is the most electronegative. So the rule says that for the most electronegative, you're going to be using the negative oxidation number. So this is, in other words, like the same as having, instead of nitrogen, the ion nitride. Do you remember what is the charge of the ion nitride? Do you remember what is the charge of the ion nitride?
-4.
Here, the ion nitride is right here. Take a look. So that means that for this case, nitrogen is going to be using the charge of -3. Okay? So with this value, we're going to be able to solve it. So we say, we need to find carbon. Okay? So we say, 1 carbon plus 1 nitrogen equals -1. 1 as a coefficient can be ignored. So you say carbon plus nitrogen. Nitrogen is negative 3, okay? Because of the nitride, remember, we just did the process of it, okay? So we say carbon minus 3 equals -1. Carbon minus 3 equals -1. Carbon is equal to -1 plus 3. So the oxidation state for carbon is going to be +2. Now, in the case of the exercise number 30, the situation will be 2 carbons plus 4 oxygens equals -2. We are looking for carbon, okay? So this will be 2 carbons plus 4. The rule for oxygen tells you that the oxidation number for oxygen is going to be -2. So all this is going to be 2 carbons minus 8 equals -2. 4 times -2 gives you -8. Then we isolate. Twice carbon equals -2 plus 8. 8 was subtracting, and the other side will be adding. So twice the carbon gives you +6.
Positive.
And now to get rid of the 2, we are going to divide by 2 in each side of the equation. So carbon is going to be equal to +3. Now, we have some other, the exercises that I didn't highlight are those that are compounds. So I'm going to be solving 2 exercises for these compounds. I'm going to be solving the number 7, okay, and the number 11 and 12. 11 and 12 are related, that's why I'm going to solve them both, okay? So pay attention to this. It says barium in barium chloride, and the number 11 says okay. So it says that I want to know what is the oxidation number for barium. We can do it in 5 seconds if you want. Look for barium in the periodic table and tell me the oxidation number.
2.
+2. So we already did it. Take a look. The exercise is telling you, look for barium, but you can do all process or you can just take your periodic table, see if it has only one oxidation number. If it only shows one oxidation number, then just write it and that's it. But sometimes you feel like no, like you have to do the process. So you say, okay, this compound is named barium chloride. Chloride ion is Cl -1. Okay? So when you do this, you do all the process, like 1 barium plus 2 chlorine, plus 2 chlorine, and because it is a compound, is equalized to 0. Okay? This is compound. So you do all this process. Ignore the 1 as a coefficient, and remember that when you have chloride ion, the charge is -1. You isolate for barium, the -2 goes to the other side as a positive. So you can do it in the 2 ways. You could isolate, do all process like I just did, or you can just take your periodic table with you and look for the oxidation number for barium. In the number 11, it says that you need to find the oxidation number for chlorine. Okay? So, we know the rule of oxygen that says that oxygen is -2. And iron has two possibilities, 2 or 3. What iron is this? Is it iron 2 or iron 3?
3.
It is iron 3. How do I know that? Because of this 3 that is outside the parentheses. Remember that the atom is being crossed from the charge, okay? Remember that when you crisscross the charges, they go to the opposite directions. So this 3 indicates that actually iron is using 3 plus as a charge. So with this, you can actually solve the problem. And you say, take a look here. When you have parentheses, like I have here, okay, when you have parentheses like you have over there, what I suggest is that you include the invisible one over there. So the number that is outside the parentheses multiplies everything that is inside. So the 3 outside multiplies the 2 from oxygen and the invisible one from chlorine. But it's not going to multiply iron because iron is out the parentheses. So you say 1 iron plus 3 times 1 chlorine plus 3 times 2 oxygen. Because it is a compound, it's equalized to 0. 1 as a coefficient, you can totally ignore it. And solve for the multiplications. Now substitute by the information that you know. Iron is 3, and chlorine oxygen is -2. And what you do after is you will solve for the multiplication. 6 times -2 is going to give you -12. And now you will solve for this. 3 minus 12. 3 minus 12 gives you -9. So you have 3 chlorines minus 9 equals 0. Equals 0. So you isolate it. You start isolating chlorine. So you say 3 chlorine is equal to 0 plus 9. 9 was subtracting, so it goes to the other side by doing an addition. Okay? So 0 plus 9 gives you 9. And then to get rid of the 3, you divide by 3 in the two sides of the equation. So in the end, what you will have is chlorine alone equals to positive 3. And with this, you solve the exercise.